Hello. Today I'm going to run some benchmarks on my uh, graphics card. It's an Nvidia RTX 3060. And I would say that this is probably um, the the worst of the good cards. And what I mean by that is I would recommend it to people, but it's at the bottom of what I would recommend. Everything else that I would recommend would be better than this. However, if I had this was my only option, I wouldn't be too upset. It's not a bad card. So we've got a Stable Diffusion 1.5 model loaded, and I'm going to use a prompt. Let's say a painting of a woman holding a bucket of water by Anders Zorn and um, let's say Gil Elvgren. I'm going to use the default settings, which is 20 steps, 512 by 512 resolution, the Euler ancestral sampler, and CFGS7. Let's create a few of these. It looks like we're getting about 3.8 iterations per second. I do know that if I turn OBS off, that goes up to about 4.0 ITs, iterations. Yeah, so I've also got Chrome running and that NVI top program running. So it is a little bit slower, but it's close to what it normally is. If we turn on high res fix, it's going to take roughly a minute. Um, when you run high res fix on the automatic 1111 interface, it redraws the image. So it's almost like drawing it from the beginning at 1024 by 1024, but it's using that smaller image as a reference so that it doesn't uh, duplicate people, it doesn't create totem poles, it doesn't do any of the standard issues that you run into when you're generating larger images. Now, some 1.5 models can do 1024 by 1024, or at least 768 by 768 without distortions. But I think if you want to get persistent, good quality images from upscaling, you do need to generate a smaller image first and then use that as the basis for the bigger image. So that took 55 seconds to do that. I typically don't like to do 512 by 512 and then upscale it. My preferred resolution is 320 by 480. We're going to turn off high res fix and I'll show you how fast this is. This takes about 3 seconds to generate. So 3.2 seconds. And I can even generate a batch of, let's say, 6. And it will draw all 6 at once. And you'll notice when it drew that 320 by 480 image by itself, it was getting 7 iterations per second. When it drew all 6 of them at once, it was getting 1.5 iterations per second. So that took 14.2 seconds to draw 6 images. Now you might be wondering, that's interesting because it took you 3 seconds to draw 1 image. Why did it only take less than 15 seconds to draw 6 images? That's because there's a little bit of overhead just to drawing 1 image. So in reality, this is like 2.5 seconds plus that 1 second of overhead. Whereas you draw 6 images at once, you're getting that 1 second of overhead or 2 seconds or however many. And then it's able, once it gets past that, it's able to draw the images at its regular speed. So 3.2, we do 6. You would expect this to be 18, but it's actually a little bit more efficient than that. So I don't stop at 320 by 480. I want to upscale that. So let's go back down to one image at a time. And we're going to turn on the high-res fix, and you'll see it says from 320 by 480 to 640 by 960. And this is actually a great size, a great intro size. I know some people love to upscale to 2000 by 4000 or whatever, but this to me is enough for the AI to be able to draw a decent picture. It's enough, there's enough space. It can do detail, it can do the full composition. Um, and yeah, this is just a kind of a sweet spot. So this one right here with high res fix on took only 20 seconds. Now, if you remember when we did that 1024 by 1024, that took almost 55 seconds. So this is much faster to do. So I can create one of these images basically every 20 seconds or 3 per minute. In fact, let's do the same thing we did earlier now and create a batch. Now earlier I did 6 images for the small images. Let's do 3 of the big images at once. So it'll draw 3 side by side at the same time. And you'll notice we're getting about 2.8 iterations per second on the small images. And then on the big images, it's taking about, let's see if it levels out, it's taking about 2 seconds per iteration, or 2.8 seconds per iteration. Now, the reality is it's drawing 3 images at the same time. And in doing so, it is, you really want to multiply that by 3. You're really getting 3 iterations in that time frame because you're drawing 3 and it's just treating them as one image. You'll also probably notice that my memory usage goes up when you create, batches of images at the same time. Batch size creates them at the same time. Batch count creates them one by one. So we'll do one as a batch size, and then we'll do another one as a batch count. So that took 1 minute and 6 seconds to do 3 images. And at 22 seconds per image, that's actually very close. 22 times 3 would actually be 68 seconds, which would be, or no, it'd be 66 seconds, wouldn't it? So that's almost exactly 3 times the thing. We didn't get a benefit from doing them like this, is what I'm saying, as opposed to doing the 6 small ones. So we did 1 minute 6 seconds for a batch size. Now let's do batch count. And like I said, this will draw them one at a time. So here's the first one. So of course that first draw is very quick. We were getting 6.7 iterations, and now we're getting about 1 iteration per second. And since we've got 20 sampling steps, that means it's going to take about 20 seconds, because each iteration is a sampling step. All right, now we're on the second one. And again, that initial draw is very quick. So it looks like, from what I'm reading on the command line, it looks like they're taking about 2 seconds for that first drawing and 19 seconds for the second drawing. So about 21 seconds. And you can see the total progress. We basically did 120 steps, although technically we did 60 low-res steps and 60 high-res steps. So there you go. 3 images took 1 minute and 7.9 seconds. So, 1 second difference, basically. 1.5 seconds. The next thing I'm going to do is change my sampler to, my favorite sampler is DPM++ 2M Keras. Let's just create 1 image of that. I believe this is a little bit more expensive, but I think the time generation is not that different. The DPM++ 2M samplers are still relatively fast. So again, that took 22.7 seconds with using a different sampler. The image is kind of weird. There's a ghost hand coming here behind the bucket. Now, so what some people like to do is they like to upscale by image rather than by latent. When you use a latent upscaler, you have to set your denoising pretty high to get a good result. And the result is not going to look like the first picture. So if you went through a batch of small resolution pictures and found your favorites and then upscaled them with latent upscaler at a high denoise, the new pictures won't look exactly like the old pictures. To get around this, though, you can upscale by image. So we'll pick a non-latent upscaler. We're going to pick 4x ultra sharp. And we're going to change the denoising strength to be very low. We're going to make it 0.15. And I'm actually going to recreate this image. Use the same seed. And I'm going to pull this one out and open it. Right? And let's make the base image first. The small resolution. We're going to save that in its own tab. So we've got our latent upscaled image. We've got the original. And now let's high-res fix with ultra sharp and low denoise. Of course, the first one draws very quickly, and you'll notice the second one, well, it started drawing quickly. It's doing a different upscale method, essentially. But it's getting about the same performance, I'd say. So this is our original, this is our latent upscale, and this is our image upscale. Now the image upscale is more faithful to the original image. The latent upscale is different, but it keeps the colors, the composition, the subject, it keeps like the basics of the image, but it changes it. It's like a multiverse variation of the image. You can even see there's a signature up here, and it redrew that signature here. And in this one, it took the signature out because it had more space, more denoise to work with. Let's make a brand new one using the ultra sharp upscaler. So we've established these take about 20 to 22 seconds to make, 25 seconds to make, somewhere in that range. We are going to add one more post-processing to this workflow before I conclude this video. So here's our new image. We're going to fix the face, because the face is bad. The face is basically an upscaled version of the low-res face, which was bad. So we have a plugin here called, it's labeled A Detailer right here. And we're using the face YOLO V8N model. What this is a face recognition model. It will identify the face on your picture, and it'll put a bounding box around it. And that bounding box is used as the basis for another pass, another redraw of just the face. But since it's now working at the higher resolution, it has more to work with. This does add time to your generation, of course. But you'll actually see a little red box appear around the face as the final stage, the face detailer, or the A detailer as it's called in this one, does its thing. Here it comes. See, it finds the face, it zooms in, it redraws, and now we have a better face. Let's do that again. That took 28 seconds. So it's adding, you know, somewhere between 5 and 7 seconds, I believe. 4 and 8 seconds, I don't know. One thing that's interesting to me is when you do a batch of these, like if I did 3 of these at once, at the end it does all the faces at once. It goes through them one at a time, and it's just zoom in, fix, zoom in, fix, zoom in, fix. We'll do a batch of 3 with the face detailer on, and that'll be my last benchmark for today. In the future, I hope to do a similar benchmark video with my new graphics card, which is a 4070 Ti Super. I've just got to put it in this machine. Give it a go. I'm excited to test it out to see how it'll change things. So we're drawing 3 images at once here. And when they're done, one at a time, it will face fix all of these 3 images. Looks like there's about 15 seconds left. Here comes the face detailer. There you have it. Better faces. And that took 1 minute and 18 seconds for a set of 3. Thank you for watching, and hope to see you soon, and have a great day.